The last 30 days has really altered our overall thoughts around our next application of sulfur and nitrogen. As you look at the state of Indiana, it's pretty vast and across the territory of what's happened. We have acres that are coming out of the ground. Corn's emerged and approaching that V1 stage, and we've got areas of the state that the planter's still in the barn. So as we look at the weather now, the next 2 weeks, it looks like a front of a lot of moisture that can move in, pop up showers. We're going to have plenty of heat. And for me, it's a good time to reflect on, depending on where you started earlier on in the discussion with the sulfur and nitrogen with the planter, what do we need to do next? And I think looking at this from knowing that we're probably going to have areas of saturation, so that could help us talk through the methodology and timing. And we also need to look back of those areas. Do we need to have stabilization? Is it going to change? Do we need to get the factory continue to build earlier in that side dress pass, or do we have time? And given the overall weather, is that side dress going to be towards the V4, V5 time? So the overall 30 days, again, as we see in Indiana, is very vast and a lot of different approaches as we dig into our strategy and after planning is complete. Now, with the timing and method of sulfur and nitrogen, it is really based upon where we're at. Now, as I move to north, I'm going to say the western part of the state up through Lafayette, more organic matter, more CEC. And a lot of times we may pre-plant nitrogen there, knowing that we can either stabilize through nitropyrin and use our variable rate stabilization prescription, but still have the opportunity to, in some cases, have went more side dress based on the overall efficiency that we can glean from being able to do a two-pass system. But really, environment is going to drive our overall strategy, but also the capabilities and what the operation as far as logistics can do and how efficient we are there. But at the end of the day, we want to optimize, especially where the markets are today and the cost of nitrogen and where the corn market is. We want to be able to get to the best nitrogen use efficiency we can, but also be able to still maintain, because we need more bushels than ever as we go into the commodity markets here over this next year. Our overall strategy of nitrogen management by environment really is multi-pronged. As I think down to the field level, for me, it always starts with environment. If we have a high organic matter, high CEC environment that tends to catch rain and lay saturated versus maybe a low OM, low CEC, we know that acre needs more overall nitrogen to build the factory, maintain the overall plant mass, and have the carbohydrate for grain yield that we need during grain fill. But once we start with that environment, then we have to isolate mechanism. How do we get the nitrogen and sulfur through mass flow into the plant? And then truly, if we have the environment, we isolate mechanism, the outcome is yield. And that outcome of yield really hinders on that overall management strategy, what Mother Nature gives us throughout the growing season. But how can we control that through building the factory? But if you go back to the strategy by environment, we have to understand the total nitrogen required. What is our history of productivity by environment in each individual field? How much total N required does it take to build yield with our bushels, but also what is the total nitrogen to maintain that factory as well? The other portion is, what is the organic supply going to be in that specific environment? As you can imagine, if we're north of I-70 and organic matter that is 3.5 or 4%, we have much more mineralization capability of that high organic matter that is going to give contribution to the crop as we warm up, as we get good overall oxygen in that soil that starts to mineralize and help feed the plant. It's much different as you get into a 1.5% or less, 1% organic matter, a CEC sub 6 or 8 in Northeast Indiana. So understanding that total organic matter supply is key to the overall plan and the prescription.